Alright, this is the video for the Algebra I Unit 4. I'm going to go through section by section. You'll notice that the numbering or the letters for the sections are not going to appear on my screen right away. So I'll kind of mark them down as we go. So starting with what you have marked as section A on your review. This whole first page is all dealing with the question whether or not the relation as presented is a function or not. And so there's kind of a few things that you need to make sure you remember. One is that when they're written the way you see them in the first group, these are all written as ordered pairs. So we call each of these pairs of numbers as an ordered pair. And when it's an ordered pair, the only thing that we need to be paying attention to here is going to be whether or not the x value of each ordered pair is unique. In other words, you cannot have any numbers that repeat in the x value. So seeing that there's a 3 here and here is the reason that I'm putting no, that is not a function. So you cannot have any numbers repeat in the x value. So looking at this next one, we have -1, -3, -5, -7. This should say -9. That's just a typo. -9. So all of those are different. -1, -3, -5, -7, and -9 are different. That means that that is a function. Looking at the next one, you might at first think because there are 4s all in the second part of each ordered pair that actually doesn't matter, because again, the only thing that matters here is that the first number in each pair is unique. We have -1, 0, 1, 2, and 3, and so yes, that would be a function. Similar idea in this next part, except now we're looking at the tables, and all we have to do on the tables is look again down the x column and make sure that the x column is non-repeating. So there cannot be any repeats. Again, looking at A, we have a repeat here. That is a no. In B, we have repeats here. That's a no. Here, these are all different. That's a yes. Here, we have repeats, -4 repeats. That's a no. So again, big idea here is like we did in class, the x value of the relation cannot repeat. If it repeats, it is not a function. Jumping down to the bottom of the page, similar idea, but now we're being presented this information in the form of a mapping diagram. And in the mapping diagram, the domain values, which are also known as the x values, can only point to one number. So each number in the domain can only have one arrow going from it. So in this first one, each one of these 5 numbers has just one arrow. That means that it's yes. In our part 2, this one has an arrow pointing to 7 and an arrow pointing to 5. So it has 2 arrows pointing from it. That's a no. And then lastly, each one of these values has a single arrow pointing from it. And so that is yes, that is a function. So with mapping diagrams, your focus is whether or not there are multiple arrows coming from a number like that you see here with that one. For example, with this 5 over here, the fact that there are 2 numbers pointing at the 5 doesn't make it a no. It's all about the domain. All right. Moving on to the second big section, or the second labeled section. We're looking at this section, which is labeled B. Here, this is our focus right here, the vertical line test. So we need to remind ourselves of what that is. So the vertical line test is a test that says if I look at a graph, it is only a function if no vertical line touches more than once. So we say vertical lines. If I draw vertical lines in this graph, there is nowhere on that graph where the vertical line will cross twice. That means that yes, this is a function. Same thing with number 2. Every vertical line that I draw only crosses once. Yes, that is a function. Now in number 3, there are many places where if I draw a vertical line, it crosses in 2 different places. That makes that one not a function. It is not a function because the vertical line touches twice. Number 4, it's only going to touch once. That's a yes. Whereas in number 5, even though there are places on the graph where it may only touch once, there are many places where it will touch twice or even 3 times, like here. And so that makes it a no. And then 6, every place on the graph only touches once. That is a yes. So the vertical line test, just reminding you, you won't have any notes for this on the test. You won't have any information about this. You're going to need to remember this, that in order to know if it's a function, vertical lines can only touch 1 time on the graph. If there are any places where the vertical line touches twice, like in number 3 or in number 5, then you're going to put a no. All right, moving on to section C. It's asking us whether or not these representations are linear functions. For it to be a linear function, the numbers must increase at a constant rate. In other words, the change from one number to the next must be the same throughout. So these are all going up by 1. -2 to -1 is 1. -1 to 0 is 1. This goes up 1. This goes up 1. So these all go up 1. That's a check for that side. Then I look at the other side of the table. This goes up 3, up 3, up 3, up 3. That checks out. If they are both consistent, like you saw here, then yes, this is a linear function. So that's what you're doing on these other ones. You're just looking at each side and you're seeing if the increase is consistent throughout. Like you see here, all the numbers go up by 1 here, all the numbers go up by 3 on this side. Because both of those are yeses, because both sides check out, then that's why we put a yes as our answer. If either side or both sides don't go up the same, then you'd put no. Pretty straightforward there, so I won't do any more of those. For the record, that was section C on your review. All right, section D on your review is what you see on the screen now. Section D is all about whether or not something's a linear function by looking at the equation. So I'm going to pop something up on the screen here. That is going to be the way that we help this, or help know this, and it's this formula sheet, or not formula sheet, this notes. This comes directly from the unit. So there are 5 main things that you need to look for. Linear functions must only have exponents of 1 on x or y. They cannot have x and y being multiplied together. X or y cannot be in the denominator of the fraction. And x and y can not appear as an exponent. And also x and y cannot appear as a radical. So I'll look at these problems and we'll talk about which rule is being broken, if any. So looking at this first problem, this is not linear. And the problem here is this x in the denominator right here. So the why not? X is in denominator. So again, going back to my notes, so you can see, the notes show that x and y cannot, neither of them can appear in the denominator. That's the rule that's being broken there for that first problem. Going back to our page, looking at the second one, this is also not linear. Why not? Because of this 2 right here. You cannot have x and y. I guess I could just say y. Y has an exponent of 2. That is the problem. Looking at this third one, it doesn't break any of the rules. X and y are not being multiplied. x or y are not in the denominator. There's no exponents to deal with, and they are there are no radicals either. So this is yes. This is linear. Again, the reasoning I just explained, they could be different on the test, so you need to make sure you have this notes that I give you in class. It should be highlighted, or you should have circled it or taken notes over this information. All right, moving on to the next section. We have our arithmetic sequences and series. The formula for this is on your formula chart. Bring that up for us real quick. Formula chart looks like this. This is your formula for finding an arithmetic sequence. You should have this so that you can use it on the test. I'm going to write this down over here. And we'll move this over.